also have Sami Huuskonen, who's design manager for Tehomet, a Valmet company, and he'll join Jani on the stage as well. Come on up, join me up on stage. Go for it, gentlemen. Thank you.
All right, thank you, Ian, for the intro. Good morning, everyone. My name is Jani Linna-Aro. I'm the Business Development Director for Orbis. Orbis provides data transmission solutions for telecom operators, data centers, building industries, and other industrial manufacturers. The company was established 70 years ago, and of course, the world has changed quite a bit during these decades. But our mission has remained the same, which is to make sure that our clients can rely on reliable and high-quality connectivity. Yesterday, we heard many great examples on new services that are being developed at the moment for smart cities. But sometimes in these discussions, we seem to lack one key element, which is the infrastructure that we need to support these services. Because the value that these services create without that supporting infrastructure is non-existing, or at least it's very limited. Let's take an example from healthcare where the service is monitoring a patient within their own home. And the value proposition is that if something out of the ordinary happens, the system automatically sends an alarm to the right party, whether that's a doctor or a relative. But if connectivity fails for some reason, the service doesn't add any value. On the other hand, infrastructure on its own doesn't create any value. A city making a significant investment on infrastructure doesn't become smart just by doing that. So we need both. So what I'm trying to say is the only way we can truly create value is that if we combine these two. So we need to break down the silos, encourage collaboration and open communication between these two domains. And that open communication is becoming more important as the role for connectivity is changing. It's becoming more critical. Where back in the days, the end result from a poor connectivity was usually bad user experience. Today, we have entire factories being automated with the help of robotics and AI. Soon we will have cars that are driving by themselves or doctors who are performing surgical procedures remotely from another continent. So if we have issues in the connectivity, the consequences are much more severe. At the same time, these new innovative services are creating new requirements for connectivity, and these requirements are getting tougher and tougher and may vary depending on the application. Some services require extremely fast networks, where others highly reliable networks with extremely low latency. And another misconception we sometimes hear is that we don't have to worry about these requirements because we have 5G coming, and it's going to solve everything. And I'm sure 5G will meet these expectations. It's going to bring faster networks with almost real-time data exchange and create networks that are highly secure and can be scaled to support the things that we add to the network every single day. But I think the real question we should be asking is how can we deploy this 5G? Because it doesn't happen overnight. 5G comes with its own challenges that we need to solve. For example, it operates on a higher frequency, which means that the distance that the signal can carry, it's much shorter, meaning that we need to have much more dense network of base stations. And how to do this, especially on an urban environment, is a problem we need to solve. We think that the infrastructure for the future smart cities will become invisible. It will be embedded in the city environment itself. But this means that we need to change the approach. We need to change the way we have been building these networks. And for that, we need new concepts. So Sami is going to continue and tell a bit more on what we have been doing in this area.
Okay, thank you, Jari. Thank you. So I will open up a little bit this framework. First of all, my name is Sami Huuskonen, and I come from Tehomet company, which is a global manufacturer of the supporting structures such as lighting poles and lighting masts. But here I'm talking about first about this framework, where we have usually in many smart city concepts we have a very technology-driven approach, but we need to also think about the user level. So the technology level, we have all these gadgets, devices, different kinds of, for example, the 5G technology. On the other hand, the sensor fusions, big data, data analytics, you know all this. But in the other hand, we have also the users, which is really important to understand who we are working with and who we will work with. So this ends up with a user-centric design approach, where we need to understand the user interfaces, interactions, usabilities, and so on. And finally, what makes this special is to understand the user experience. What are we doing with it? And the connectivity is really the crucial thing, of course, bringing, for example, the 5G networks that enables the technology to speak with the users. So our concept with the Orbis, we have discussed and doing concepts with the lighting poles turned as a technological platforms, such as what we already saw in the previous keynote speaker. So this is to build up the various smart city services. So this is like a very hands-on approach, what we are talking about. We have these different levels of lighting pole, turning the existing infrastructure as a smart city backbone, so I would say. Because we have lighting poles everywhere. That is a natural place to be integrating different gadgets and technology. So basically we have 4 different levels. First is the pedestrian level here, that we are talking about the interaction, such as, well, these are just the examples that could be embedded, nothing more. For example, these emergency buttons and so on. But also the commercial guidance and communication levels, different kind of functionalities such as smart lighting. But the network level is one of the most crucial things that we need to have, the data connection, to enable these things. And that is the main challenge that we have been facing with our different pilots. And of course, it doesn't come, we need to have some kind of operating system, IoT, cloud computing, management systems, and so on, which is really fascinating to understand that we have so many different stakeholders dealing with these things. So we need partners. It is really crucial. It's not possible to create this as a one company. We need to collaborate not only with the companies but also with the users. So we need workshops and ideas. And we need also the political level strategic designs. It is really important to understand that what we've been facing before when starting the piloting is we face up with a very top level. We don't have that kind of like a real strategy with what to follow. But we also need all these operators in many parts. We need structure engineering. We need, well, as you can see, but all in all, the transparent information through different parties. The piloting is the very essence, and I really like to emphasize this, that we need to test, we need test areas before going into the large area deployment. We need small areas to test these things. And many times when we are starting, everybody who has a computer knows that you have a new technology, well, wow, it works and it should work. And when you start working, it doesn't work as it should be. Well, in some cases it does, but mostly it doesn't. So it's the same thing when you go to this level, this scale, it's really important that we pilot these things. So we need to fail fast, fail better, but in order to succeed with the users involved. Okay, thank you. That's it.
Thank you.
Thank you very much.